In this media, you will learn about the basics and tuning of PID controller. Basics of PID controller. A proportional integral derivative controller, PID controller, is a control loop feedback mechanism. It is generally used in industrial control systems. A PID controller calculates an error value repeatedly based on the difference between a desired set point and a measured process variable. Basic tuning parameters of PID loop include 1. Gain, also known as proportional band or P-gain. 2. Reset, also known as integral or I-gain. 3. Preact, also known as derivative or D-gain. Tuning of PID controller. All the common methods available for control design are applicable to PID control. There are also a number of tailor-made methods developed for PID controller, known as tuning methods. The most popular methods of tuning were developed by Ziegler and Nichols. Their methods are based on characterization of process dynamics by a few parameters and simple equations for the controller parameters. Step response method. One of the tuning methods produced by Ziegler and Nichols is based on the process information in the form of open-loop step response obtained from a bump test. The step response is characterized by only two parameters, A and L. The parameters A and L are given by the intersections between the tangent and the coordinate axes. PID controller parameters obtained from the step response method are as shown in the table. Frequency response method. Ziegler and Nichols' second method is based on a simple characterization of the frequency response of the process dynamics. The point of intersection of the Nyquist curve and the negative real axis is the point P of S. The two parameters at this point are the frequency omega sub 180 and the gain at that frequency, K sub 180 equals P times I omega sub 180. It is characterized by two parameters, K sub U equals 1 over K sub 180, which is known as ultimate gain, and T sub U equals 2 pi over omega sub 180, which is known as ultimate period. PID controller parameters obtained from the frequency response method are as shown in the table. Thus, you have learned about the basics and tuning of PID controller.